terribly exciting environment and people that I've already met and spoken to. And I'm going to take a little bit of a different track from what we've heard so far. The title of my presentation is The Unruliness of Matter, which is what I'm looking at in my research currently. So I'm going to start with a quote by the Italian theorist Franco Berardi, where he says that the word design essentially refers to the relationship between objects and utility. Design, in this sense, encompasses both conceptual art and engineering. As art, design conceives a world for an object, and as engineering, design builds a world for an object. And this kind of world building becomes more and more apparent every day. So just a few weeks ago, Bloomberg reported that Amazon is developing a voice-activated wearable device that can recognize human emotions. And as per the release, it's designed to work with a smartphone app. The device has microphones paired with software that can discern the wearer's emotional state from the sound of his or her voice. And then it goes on to say that eventually the technology could be able to advise the wearer how to interact more effectively with others. Now, the article already notes that machines that can understand emotions are a sci-fi staple. And indeed, designers and futurists alike have been using science fiction and scenario planning for decades. Herman Kahn, who is really thought of as the person who introduced the idea of scenario planning in the 50s. And he used the term, he borrowed the term scenario from Hollywood deliberately. He said that scenarios are not predictions, but stories to explore. And what these stories do is really help us think beyond the object, the surface, the platform that we're using, that we're building, and explore them as they're enacted in a shared world. Map out and organize our thinking and situate the artifacts, and I use artifacts in a very broad sense here, we create in terms of their cultural, economic, ecological, social, cognitive, and aesthetic implications. So as the future is engineered at an increasingly accelerated rate, and we heard today, oh, this couldn't happen a few years ago, and we're edging closer and closer to the present, I think it's a good time to reflect on what we want this future to look like, and what kind of stories and experiences we want to inhabit, especially at a time when technology permeates every aspect of our life and relationships, including now our relationship with our own self. In the Amazon device, which is codenamed Dylan, a name that between Dylan Thomas and Bob Dylan evokes poetry, so closely related to words and voice, there are three distinct narratives that are emerging. First is the idea that there are vocal biomarkers from which a wide range of emotional states can be accurately inferred and that apply to a reasonable number of individuals across cultures and expressive modalities. The second one related to this is that, as we've already seen applied in diagnostic applications, is the idea that there is a level of awareness that eludes humans but is accessible to machines. And finally, there is the idea of human-to-human interaction, not only mediated, as of course it's already common, by technology, but now guided by technology. So the language used here in the Amazon press release or patent application is quite interesting, where interact more effectively with others. And it's important because, after all, the practice of engineering is often thought of as the application of scientific knowledge to achieve a set of functions and optimize efficiency. In the case of Dylan, this notion of effectiveness and efficiency is based on some bold claims and assumptions about what makes us humans, how this is expressed, and how our relationship with technology takes shape. So the lines between predictability, awareness, communication, authenticity get all a bit blurred, as is the line between human and machine. Now, it is clear to all of us here, otherwise we wouldn't be here, that as designers and engineers, we no longer only make things, but instead we're designing and engineering interactions, interfaces, conversations, and even behaviors. And therefore, I think it's critical to consider what kind of effectiveness and efficiency we are striving for. Herbert Simon, who is a Nobel laureate, economist, cognitive science, in an essay called The Science of Design, Creating the Artificial, he says that everyone designs who devises courses of action aimed at changing existing situations into preferred ones. So this, of course, involves describing what is the existing situation and mapping a journey to the preferred. So how do we get there? And what are the values and principles that underwrite where we are and where we want to go? Now, articulating these values and principles helps us create a shared language and a process of envisioning that forms the basis of a dictionary, if you will, that can translate and explore how the technical is mapped out and enacted into the world. As design and engineering is both about trade-offs and constraints, having a clear understanding of what it is that we value helps us create those principles that guide development and then can be checked against the requirements and specifications, and really try to understand what it is that we're willing to give up, what qualities, attributes, and agency we assign to machines, and what to humans. So one good place is to start, indeed, with assumptions. As engineers, these new situations that we create, we make assumptions about the world. Assumptions mostly based on our existing models and data sets. And we've already seen on multiple occasions how this can be biased, normative, and reductivistic. And while we have become fairly adept at modeling the technical development of engineering systems, we are much less adept in modeling their political, ethical, and aesthetic implications and the ecosystems they create. And again, it is important to note that we are developing not singular interactions, but instead complex ecosystems. So to borrow a term from chip manufacturing, we can really start by engaging in what I call a heterogeneous interaction of sorts, right? So we integrate design and engineering not as distinct phases, but as an iterative and enmeshed process of world building, and one that spans across disciplines and ways of thinking. By articulating the assumptions we make about the world and look at models that question and possibly disrupt these assumptions, we develop a new appreciation for both the importance of the language you use and the limits of what we can see from our siloed domains of knowledge. As the mathematician and truly interdisciplinary thinker Benoit Mandelbrot once said in an interview, he said, the problem with calculations is that they become very much specialized in their different fields. On the contrary, the eye is not specialized. It is a universal tool. So how specialized do we want the calculations about who we are and want to become to be? And speaking about seeing, another famous polymath, Professor Jerome Letvin, that traveled between many disciplines. He was trained as a medical doctor, was a practicing poet, and a professor of electrical and bioengineering at MIT. In 1959, published a paper that at the time was met with much skepticism and even ridicule. But of course now is considered as a seminal paper in cognitive science. So in the paper called What the Frog's Eye Tells the Frog's Brain, he demonstrated that in frogs, the eye speaks to the brain in a language already highly organized and interpreted. So instead of transmitting some more or less accurate copy of the distribution of light on the receptors. So in common parlance, that means that they discovered that a lot of what was previously thought to occur in the brain was actually happening in the eye itself. And now in 2014, Professor Hans Hutt and his team, they demonstrated that more than 15 of the olfactory receptors that exist in the nose are also found in the human skin. And they later also identified those olfactory receptors in several other organs, including the liver, heart, lungs, colon, and brain. So in fact, genetic evidence suggests that nearly every organ in the human body contains olfactory receptors. So that's a very weird thought to have. There are many more examples from the world of physics, chemistry, and biology that show that the assumptions that we make about the world and the models that we base our understanding on it are continuously disrupted. And we've heard this earlier, and we're going to keep hearing it, I think, the rest of the day. And they expanded out, and of course, outside the basic laws of physics, we live in a world that is infinitely complex and varied. And we are at a time where we have the tools and the technologies to engage with its complexity in an unprecedented manner. And in this variability is nowhere more evident than in the material world. Complex, unpredictable, stubborn, and hard to model, what I call the unruliness of matter. So what does the unruliness of matter have to do with design meets technology? Well, acknowledging and understanding the complexity of the material world opens up a space that allows us to question the reductivistic models of what it is to be human and how we create and how we relate to our exterior and interior environment, and can act as this point where design as planning and organizing meets engineering as a practice of making. It is a point of convergence between thought and action, but informed by the embodied and the variable. Our history as humans has always been defined by the materials we invent and the uses we make of them. In many ways, our own evolution is mirrored by the evolution of our material needs, and new materials in turn create new possibilities for being in the world, expressing who we are, who we want to be, and how we connect with ourselves and with each other. But as this materiality becomes more and more immaterial, as artificial intelligence, which really at this point is another name for software, information flows and data are becoming the very material that constructs our world, and the notion of needs, meeting our human needs, itself is somewhat revisited. So what can we learn from the unpredictability and complexity of matter? For one thing, we know that we're not very good at modeling how materials behave in the real world. So Professor Narzari, who is also a lead, who leads a project of Material Cloud, where they're trying to design, to enable the seamless sharing of resources in computational materials, cautions that the predictions themselves have errors and often work on a simplified model of materials that doesn't take into account the real world. There are all sorts of environmental factors like temperature and humidity that affect how the compounds behave. So while Professor Mazzari is concerned with computational materials, the challenges of modeling the interactions between materials and the environment, the real world, what we call the real world, can be directly mirrored in the challenges of modeling and integrating the complex stack that is emerging, where language, how we describe things, algorithmic intelligence, human needs and aspirations and their environment, material, cognitive, emotional, etc., all come together. Like in the case of the compounds that Dr. Marzini investigates, the difficulty in modeling and predicting the outcome of complex interactions and systems is that we fall short in accounting for all the variables that come into play. And this is nowhere more evident than when dealing with the material world. So the stack of a language, algorithmic intelligence, human needs, and aspirations forms a context of inquiry, an undistributed surface that designers are well placed to draw out, to delineate the interior and create exterior spaces that are created, and where meaning and action is usually situated and embodied. And it is this very embodiment that the intricacies and complexities of matter and materiality can help explore and literally allow to question of ethics to emerge. And by ethics, we really mean, how do we really want to live, right? To materialize. And therefore probe the boundaries and opportunities of the hybrid materialities we are creating and provide the perfect setting for an iterative and interdisciplinary practice between engineering and design. So this hybrid materiality and how we respond to it becomes very apt in the engineering of computational materials. As Gregory Abod, who's a professor of interactive computing at Georgia Tech, he says that merging wearable devices with the Internet of Things results in the Internet of Nouns, a digital universe of people, places, and things that mirror their counterparts in their physical world. So this Internet of Nouns constitutes a shroud that envelops the physical world, that continuously updates and reacts to changes in that world, facilitated by the cloud. So I've been working with Professor Abode and his engineering students to imagine the world that would come about if every surface was indeed computational, as they imagine, and in a constant interplay between the physical and the virtual. So while questions about privacy are an obvious concern and one that the students are really trying to address, the demands and rigors of engineering leaves little time for them to extend beyond the boundaries of their practice. So our work together is structured in terms of articulating the values and principles that are important to them as a group and use them as a framework that guides prototype development. We also explore the materials and phenomena they experiment with, such as microvibration, multimodal interactions, self-sustainable surface, ubiquitous sensing surfaces, and already these words are really, the language that we use to describe these are quite, I think, important and critical, and try to understand them in terms of their cognitive, emotional, and environmental load. We're also looking at what kind of new opportunities these materials can create, much as we've heard earlier, and what can they reveal? So instead of trying to apply them to existing use cases, we try to explore them almost as alien technologies that can create new types of interactions that we never really thought of before. So using the adage that is often attributed to Henry Ford, that if you asked people what they wanted, they would tell you a faster horse, we're working together to imagine interactions and applications that, again, except from the basic laws of physics, are unbounded by what we expect things to do, and look at materials as oscillating interdimensional structures. And finally, we're trying to explore how we can measure materials themselves, what the physicist and Nobel laureate Frank Wilczek calls the quantum atmosphere, this thin aura or zone of influence that surrounds materials. As we move forward to imagine the future, I think it's always instructive to also look back and learn from the past. Annie Albert, our leading figure of the Bauhaus, celebrating 100 years this year, who constantly experimented with materials and material practices, wrote, "Materials have accumulated to themselves a set of rules for working with them. In going back to the fundamental principles, we can open the field again for invention, imaginative use of intellectually recognized facts." So for the Bauhaus auditorium, she wove a material from linen, raffia, and cellophane that behaved like a wall and reflected light and absorbed sound, reflecting the Bauhaus mission to apply artistic creativity by learning with and from materials so that they could give shape to the modern age and meets its many demands. And boy, are our modern demands really moving on. And where aesthetics and function were seamless and, excused upon, woven together. Same with Quipu's, Incas, artifacts from the Incas that we've only learned about 30 years ago that they were very complex algorithmic devices. Again, think about it, tactile, worn algorithmic devices. So what lessons can we learn from our rich material culture as we move forward, and how we can make connections between the past and the future and our combined practices? So Sana Zhubov, in her last book, Surveillance Capitalism, calls for the right to sanctuary and the right to imagine the future. More than 20 years before Zhubov, Donella Meadows, the systems designer and co-author of The Limits to Growth, wrote, "If we haven't specified where we want to go, it is hard to set our compass, to muster enthusiasm, or to measure progress. But vision is not only missing almost entirely from policy discussion, it is missing from our culture. We talk easily and endlessly about our frustrations, doubts, and complaints. But we speak only rarely and sometimes with embarrassment about our dreams and values. Looking beyond privacy and efficiency and focusing on trust, respect, playfulness, serendipity, beauty, cooperation, and collaboration seems like a good place to start imagining the future we want to live in. After all, the present moment used to be the unimaginable future. So, bringing design and engineering together in a systematic and considered way in order to build a shared vision of the future, accounting for the embodied and material in all its complexity, unpredictability, and variability as part of the computational and the digital is, I think, a good path away from the poles of utopia and dystopia. Thank you. And I had to put that in.